in chapter 1, we're going to talk about combinational logic gates. Okay, I'm going to talk about combinational logic gates. We're going to be studying the different types of combinational logic gates and circuits. So to start with, we're going to examine what a combinational circuit is. Okay. So we're going to examine what a combinational circuit is. So what is a combinational circuit? So a combinational circuit is a circuit in which, okay, so it's a circuit in which different gates, the circuit in which different gates are combined. Different gates are combined to make the circuit. Okay, so this is a circuit in which different gates are combined to make the circuit. Okay, or you can still say it's a circuit made up from a combination of different gates. Circuit made up from a combination. If you want, you can say from the joining, linking, or cascading of different gates. So that's what a combinational circuit is. So whenever you get different gates, you cascade them, or if you want to say you join them, you link them, or you combine them. The circuit that you come up with is called a combinational circuit. So that is what a combinational circuit is. So an illustration, a simple illustration will be, let's say you get an AND gate. I'll draw some buses here first, some signals. Let's say you have signal A, signal B, you have signal C. Okay, this is a small gate signal. You have a simple AND gate here, another simple AND gate. They're all running into what? Running into an OR gate. And the output, we call it X. So let's say A is running into the signal, and B inverted is running into the signal, and C is running into the signal, and V is running into the signal. So the fact that you have one logic gate, another logic gate, and another logic gate, and they're interconnected, this system that you have is called what? A combinational logic circuit. So what are the characteristics? Okay, characteristics of combinational circuits. Characteristics of combinational circuits. Characteristics of combinational circuits. Okay, so the characteristics of combinational circuits are such that the first characteristics is one. If you want to identify a combinational circuit out of all different circuits like counters, registers, sequential circuits, what are the characteristics that you use to identify a combinational circuit? One, you're going to identify that the input or the output of the circuit depends only on the input values, or if you want, you can say input signals or levels. Okay, so in a combinational circuit, what is going to happen is that the output that you get on X depends on the type and also the magnitude of the signals that you enter into the circuit to give you X. So unlike in other circuits, for instance in sequential circuits, when you talk about flip-flops and latches, so maybe in a flip-flop, what would happen is that the output does not entirely depend on the on the inputs that you put into the circuit here. So what happens, I'll give an example of a flip-flop, right? It's just an example of flip-flop. So example of a flip-flop that I'll give, the way a flip-flop operates is that I'll use this example here. Let's say that you had put some input, four input signals here, and then the first result that you got as X was what? Was a 1. Okay? And then the second result that you get as X is what? Is 0. So what is going to happen is that this is the first result, right? And this is the second result. So when you're working with sequential circuits, what will happen is that the first result that you get from the calculation will be used as another input here, as another input for you to get the what? To get the second result. So meaning the previous result is used as an input for you to get the second result. And the chain keeps on going like that. So again, this result will be used as an input here for you to get what? To get the third result. Let's say your third result is now going to be equal to what? 1 again. Maybe your fourth result is going to be equal to what? To 0 again. So from the what you get as a first result, the first result will be inserted in the inputs for you to get the second result. Then the second result will be added as an input here for you to get the what? To get the third result. The third result will be added as an input here for you to get the what? To get the fourth result. But that is not the case with combinational circuits. So in a combinational circuit, if the first result that you got was 1, the circuit forgets all the calculation it did, it resets. And then if you add other inputs, the calculation, the circuit will calculate a different independent result of what? Of 0. And this result here has nothing to do with the previous result. And this result has nothing to do with this previous result. And this result is not used. And this result is not used as an input for you to get what? For you to get this result. So in a combinational circuit, unlike sequential circuits, in a combinational circuit, the output that you get here at X depends only and only on the inputs. Okay, only and only on the inputs that you insert on this steering gates here. Okay, so that is what it means. So input is directly proportional or equivalent to the what? Output is directly proportional. Sorry, output is directly proportional to the what? To the input. That is how combinational circuits work. So the second characteristics of combinational circuits is they do not use memory. Do not use memory. They do not use memory. Okay? They do not use memory. So for you to understand that they do not use memory, you have to define first of all what memory is itself. Okay? So in electronics for computing one, let's talk about what memory is. Okay? So the first concept about memory in electronics for computing 2, sorry, not 1, electronics for computing 2. What is memory in electronics for computing 2? Memory is when the previous result is the same as the next result. Okay? Previous output similar to next output. Okay, that is what memory is. When the previous output is similar to the next output. So for instance, let's say in a circuit, the output of X is equal to what? 1. The first output is 1. And then you realize that the second output is also what? Is also 1. The fact that the previous output was 1 and the next output is what? Is 1. This means that the circuit remembers the value it calculated later on. That is what the assumption that we make in electronics for computing too. So when the two consecutive results are the same, okay, that is what you call what? Memory. 2. The second concept about memory is the fact that previous, okay, the previous output is used as input Previous output is used as input in next operation or calculation. Okay, so when you have a circuit and then it functions in such a way that let's say the first output of x was what? Was 0. And then you get this 0 and then you use it as an input, okay, as an input for you to get the next output of 1. So whenever you use the output of a calculation as an input in the next calculation, that is what you call what? Memory. So when they say that combinational circuits do not use memory, they mean that first of all, consecutive results are most likely not to be the same. Two, it means that the previous result that you have cannot be used as an input in the next what? In the next operation. So when they say conventional circuits do not use memory, that is what they mean, or that is what it means. The third characteristic. What is the third characteristic of a combinational circuit? Okay, so they have n inputs and m outputs. They have n inputs and m outputs. What does this mean? This means that we know from mathematics that n is not equal to m. So if n is 2, it means m can't be 2. M has to be a different number, less or greater than 2. Okay, so if this is 2, this might be even 5 or something, and these are not equal. That is what I mean. N is not equal to what? To m. So they have n inputs and m outputs. This means that, for instance, I'll draw a block diagram for a circuit. They try to tell you that a circuit might have any number of inputs. It might have, let's say, 3 inputs and yet have 1 output. Okay, and in some cases it might even have 2 outputs, like that. But all the same, they're trying to tell you that the number of inputs and the number of outputs sometimes may not be the same, and sometimes it may be the same. There is no hard and fast rule about it that the number of inputs and the number of outputs must be the same, or they must not be the same. No, anything can happen. The number of inputs and the number of outputs might be the same, or might not be the what? Might not be the same. So under the characteristics, so that's the end of characteristics about what? About combinational circuits.